Throughout the past year that I've been involved in the flat earth debate, anytime someone asks about how the sun sets and rises, it's always the same response from the flat earth side of the argument: perspective and the vanishing point. They all claim that the sun gets to a certain distance and can no longer be seen because it goes beyond the vanishing point. What they never answer is, at what distance is the vanishing point? In this video, we will examine what distance that should be at. With it being the equinox, it's the perfect time to take these kinds of measurements. Basing it all off the equinox, it's very easy to make a model to find out what that distance is. After all, we know the exact position of the sun over the disk, and we know the locations of any observation points. Let's look at the model they propose most often, the circular disk. As you can see, on the equinox, the entire Earth gets 12 hours of daylight and 12 hours of darkness, give or take up to 4 minutes depending on topography. Let's put the sun into motion to show its path over the disk Earth on the equinox dates. As you can see, it is always directly over the equator. What this means is it's always the same distance from the North Pole. Now, let's stop the sun on the right side of the video and look what the model would look like if you were able to place a camera locked to the sun. From the sun's perspective, the Earth is rotating underneath it. Nothing about the model has changed. This is just a way of showing the measurements easier later on in the video. Now we can pick 3 observation points. For this demonstration, I'm going to choose Long Beach, New York, Chavez, Brazil, and Ushuaia, Argentina. We know the distances of each of these points from the North Pole. Long Beach in New York is 3,422 miles from the North Pole. Chavez, Brazil is 6,226 miles from the North Pole. And Ushuaia, Argentina is 9,986 miles from the North Pole. We also know the distance from the equator to the North Pole is 6,215 miles. If perspective and the vanishing point really is the cause of the sunrise and sunset, all these distances should be the same, as the laws of perspective apply to everyone in the world in the same way. Let's go ahead and stop the rotation of the disk at each of these points in turn to see how far away the sun is at dawn at each location on the same date, March 20th. First, we'll take a look at Chavez, Brazil. To find out how far away the vanishing point is, we'll make right triangles. The first leg of the triangle will be from Chavez to the North Pole. The second leg of the triangle will be from the North Pole to the equator at the sun's location. To find the distance to the vanishing point, we'll need to make use of the Pythagorean theorem. First, we need to make a line from Chavez to the North Pole with a distance of 6,226 miles. We will call this leg A. Next, we make a line from the North Pole to the sun with a distance of 6,215 miles and call this leg B. To find the distance between each of those 2 endpoints of the legs, we need to use the formula to find the hypotenuse. To get our distance to the sunrise, it is the square root of A squared plus B squared. So from Chavez, the vanishing point is 8,797.12 miles away. Now that we have our baseline, let's move on to Ushuaia, Argentina. We know that Ushuaia is 9,989 miles from the North Pole. So we just run through the calculations again. We draw a line from Ushuaia to the North Pole with a distance of 9,986 miles. Then we just draw another line from the North Pole to the sun, which we already know is 6,215 miles. Now we just run through the same calculation and end up with a vanishing point distance of 11,762.08 miles. Uh-oh, we have a problem here for the vanishing point. Let's go ahead and test our last location to see if the problem fixes itself. Moving on to Long Beach, New York. We already know that it's 3,422 miles from the North Pole. So again, we draw a line from Long Beach to the North Pole with a distance of 3,422 miles. Now we draw our line from the North Pole to the Sun's location with a distance of 6,215 miles. Now we solve our equation one last time to get a vanishing point distance of 7,094.81 miles. So, as you've just seen, unless the laws of perspective change based on your latitude, all on the same day, the entire perspective and vanishing point arguments are complete rubbish. I would like to thank fiveredpears and Goudsmits for inspiring the idea to make this video with ones they touched on the topic but didn't go into a whole lot of detail on the math. And I'd like to give a very special thank you to Halsoy for actually doing the animations for this video.